Okay, we're going to talk about how your brain works. This is part one. We're going to talk about the vertical organization of the brain. It's based on a concept called the three-part brain of MacLean, sometimes also referred to as the triune, three-part brain, another way of saying it. Okay, so the first part of your brain is what's called a reptile brain, and that's your brainstem. This would be the equivalent of, let's say, your medulla, your pons, and your midbrain. Basically, the theoretical evolutionary framework is that older stuff stays there, but the new stuff is built on top of it. So a reptile doesn't need to do much. A reptile just lays an egg and can walk away. Reptile males don't worry about the financial implications of divorce. All right, so anyways, a reptile, primitive brain, it can control your heart rate, blood pressure. Reptile brain, like I said, pretty simple. It wants some food, it cares about survival and replication. One can joke it's a little bit like the id, real simple primitive desires. Okay, so that is part one of the brain. Part two of the brain is what is called the limbic system, or the mammal brain. It's shaped like the letter C. Kind of looks like the C on the Chicago Bears helmet. So anyways, the letter C for limbic brain is associated with mammals. They call it the mammal brain. And a mammal is different than a reptile in the sense that a mammal has a family, in the sense it nurses its young, it cares more for its young, spends a little more time helping them get started in life. The mammal brain tends to be fast, quick, reactive, emotional, impulsive, but it's very fast. And there's a famous book called Thinking Fast and Thinking Slow by Daniel Kahneman. He won a Nobel Prize. And one way you can think of it is the limbic brain is sort of your fast, quick, emotional brain. And it works well for things you do on autopilot that are automatic, reflexive. Things that you do every day, you can do them without even thinking. Like if you're walking, you can have a simple conversation and say, oh yeah, what is 2 plus 2? 2 plus 2 equals 4. And you can walk and you know that it's not a big deal. But if somebody asks you a more complex thing, you would have to stop and go, let me think about that. So this is for stuff that's effortless and fast. All right? That's relevant, but it's also real emotional because an animal has to react fast. It's a little bit of your quick, fast brain. You can think of it that way. Then comes the human brain, the cerebral cortex. Neocortex for new cortex. Cortex, like in Latin, means bark of a tree. Like if you look at a tree stump, on the outer part is the bark. Cerebral cortex is just a coating on the outer side of the brain. It's only about 2.5 millimeters thick. And this is for more slow, effortful thinking. And this is also, if you want to use the Freudian terminology, your ego, superego tend to be localized at that part. But anyways, so this is a three-part brain, and then how is this useful to you? It's to recognize when you're emotional. Like sometimes you're upset. Let's say you're dealing with your significant other, okay? If you find yourself being kind of upset and emotional, a lot of times you want to just say, let's talk about it tomorrow. Sometimes you want to resolve the issue before you go to bed, all right? But what I'm trying to say is, you notice that you function intellectually at your best when you're in your cerebral cortex mode. And by the way, sympathetic autonomic nervous system stress, SANS, will have a tendency to push you into this mammalian reactive brain. I think it's because when you're in a fight or flight stress situation, you don't need a lot of blood supply to your frontal lobes for complex decisions. You just need to run or climb a tree to get away from a dangerous situation. And the point is, you sort of shift into that mammal reactive athletic mode rather than this thoughtful, slower cerebral cortex mode. And so that's why, too, let's say you're talking about students. I see all these college students, they pay so much money for tuition and most of them don't even know how to study. It's kind of a big joke. And what I'm basically saying is, I never did an all-nighter. I know the guys who are getting A-pluses at Stanford. When I was in med school, I interviewed all the top 10% students in the class and wrote a book about it. And what I'm basically saying is, if you over-prepare, you don't need to stay up late. You sleep, and then you come, you show up for the test, you're in a cerebral cortex mode, and you do better versus somebody who's anxious and not sure if they know the material. We'll talk about study skills in another video, but the point is, you want to be in cerebral cortex mode to the extent you can. So anyways, this is the vertical organization of the brain. Reptilian brainstem, mammalian limbic system. This is sort of on the medial part of the brain. This is a cingulate gyrus continuing through the isthmus into the hippocampus and parahippocampal gyrus. And here's cerebral cortex. By the way, the cerebral cortex, it kind of looks like a fist. And you can look at your own fist. This is your temporal lobe. The little dividing line separates frontal lobe from parietal lobe, and in the back is occipital lobe for vision. So that's vertical organization of the brain. And in subsequent lectures, we will cover the brain from viewing it in other ways. Basically, it's like you asymptotically approach the truth. You don't never get there 100%, but each new metaphor and concept gets you closer to more precisely perceiving how the brain works. And the reason you want to do this is that's part of being smart. The more you understand your brain and yourself and your personality, the more you can effectively interact with other people and also optimize your performance. So, okay, that's it for how your brain works, part 1.